Question number 2, mountain climbing. One of the problems experienced by mountain climbers is the persistent cold at higher altitudes. In fact, as altitudes increases, air temperature decreases. The graph of air temperature as a function of altitude on a warm summer day at Mount Everest is shown. Use the graph to answer the following questions. A, what is the air temperature at sea level on this fine day? This is the temperature, 0 altitude, 1,000 meters, 2,000 meters. The 0 altitude is sea level. When the altitude is 0, the temperature is 30 degrees. What is the temperature at an altitude of 4,500 meters? Here's 4,000, here's 5,000. 4,500 is right there. You can see that the temperature is 0. By how many degrees does the temperature vary over a 1,000 meter increase in altitude? As the altitude increases by 1,000 meters, how much does this change? We're going to look at the slope, or we can look at this part of the line. We know that it's going to change by 30 degrees over 4,500 meters. We know the temperature goes down 30 degrees in 4,500 meters, and we want to know how many degrees does it go down in 1,000 meters. We can set up a proportion like this, cross multiply. That gives us negative 30,000 divided by 4,500. Chop off the zeros. Chop off these zeros, so you have negative 300 divided by 45 gives us negative 6.6 repeating, almost negative 7 degrees. Negative 6.6 repeating degrees Celsius. D, give the rule of correspondence of this function between the altitude and the temperature on this day. This is a straight line. We know the B value, the initial value, is 30 degrees. We don't know the slope. We need to find the slope. This is kind of the slope. This is kind of the slope. Delta y over delta x is negative 30 over 4,500. If we start here, this is our point 1 and this is our point 2, then our delta y is, we went down 30, our delta x is, we went over 4,500. Negative 30 over 4,500, which we can chop off the zeros and say negative 3 over 450, and then divide the top and bottom by 3. That's going to give us negative 1 over 150. Then we know the b, so we have the equation. F of x is equal to negative 1 over 150, x plus the b value plus 30. That's our equation. Carry out a thorough study of the properties. What are the properties? We have the domain, the range, the zero, the y-intercept, the maximum, the minimum, decreasing, increasing, positive, negative. The domain is, look first at the mathematical model. The mathematical model is a linear function, and its domain is all the real values. The x values are all the real values. The range, the y values, is going to go up and up forever and down forever, all the real values. The zero, where does it cross the x-axis? When y is equal to 0, what's the x value? It's 4,500. The y-intercept, the initial value, is 30. The maximum, there is no maximum. It's going to go up forever. There's no minimum, none in both cases. When is it decreasing? Well, it's decreasing for the whole domain, right? It's decreasing for all the x values when x is a member of the reals. When is it increasing? We don't list it. It's not, never. When is it positive? It's positive from here, keeps going from negative infinity, it keeps going up this way, until we get to here, until we get to the 0. When x is a member of negative infinity, projectile bracket on negative infinity, to the 4,500. When is it negative? From 4,500 to positive infinity. Look at the actual context of the situation, not just the model. The context of the situation, the domain, what happens when you get to the altitude of less than 0. We're not looking at below sea level because sea level is as low as you're going to go, 0 until 9,000 meters. That's the context of the situation. The domain is from 0 to 9,000. The range is, the lowest we're going is negative 30. The highest we're going is 30, negative 30 to positive 30. The 0 is the same, it's 4,500. The y-intercept is the same, 30. The maximum is not the same because now we have a maximum, 30, and we have a minimum, negative 30. When is it increasing or decreasing? Well, it's decreasing over the full domain from 0 to 9,000. When is it positive? It's positive from 0 to 4,500. When is it negative? From 4,500 to the maximum x value, which is 9,000. F, given that the temperature at the peak of Mount Everest is negative 29 degrees Celsius on this day, find the height of Mount Everest. We have a nice function that we can use. We are going to replace the f of x, which is the temperature, with negative 29. I want to get rid of this 30. I'm going to subtract 30 from both sides, and that gives me negative 59. At negative 1 over 150, it's like we're dividing x by negative 150. So if I multiply both sides by negative 150, we end up with 8,850 meters, okay, is the height of of Mount Everest, according to the temperature altitude graph. All right, and that's it for question number 2. Have a good day.